Hello and greetings from Riga, Latvia. My name is Gailitis, and today I can tell you about reinforced and plain geopolymer concrete specimen cross-section composition influence on creep strains. The aim of this study was to determine the loading influence on geopolymer concrete long-term properties, as well to determine the long-term properties for two different geopolymer concrete mixes, one with steel cord reinforcement and one without, and also to determine microstructure influence on geopolymer concrete long-term properties, and to deduce whether there are any links between long-term properties and changes into microstructure composition after loading. So geopolymer concrete is three-dimensional inorganic material. It is based on silicon and aluminum reaction that is released by hydroxide silicate. Some authors claim that geopolymer is the concrete for 21st century. But main reasoning to do researches on geopolymer concrete is the environmental benefits that it bears. Basically, by using geopolymer binder into the concrete, the CO2 emissions can be reduced up to 6 times, in contrast to using Portland cement binder. Furthermore, sustainability-wise, I bet that every one of us in our daily routine use some kind of transportation, and this transportation has tires. And for this instance, 17 million tons of car tires is made every year into the waste material. And even though they are recycled, not all parts of tires can be recycled because rubber has a market. It can be recycled into floor mats, shoe soles. But as for the reinforcement, like steel cords or wires, they don't have any market to be resmelted. So it can be, in my mind, used as a fiber reinforcement. So for the testing purposes, two mixes were prepared. One geopolymer mix that didn't have any reinforcement, and one that had 5% steel cord reinforcement from recycled tires. Specimens were made into the shapes for the creep and shrinkage testing. Creep was tested into creep lever test stands, as it's visible on the top images, but on the bottom images you can see the shrinkage specimens that are placed in specific test stands. Measurements are done simultaneously at the same lab, at the same environment. So after long-term testing, polished section samples are prepared. They are cut from the tested specimen middle parts, cut into 5mm thick disc shape samples. They are saturated with the polyester resin, and after curing, they are grinded and polished so that, as it's visible on the bottom image, only the pores are filled with the polyester resin, and the matrix filler and reinforcement is visible. After polishing, the polished sections are placed into heat chamber at 40 degrees for 5 days so that the excess moisture can evaporate, and afterwards samples are placed into Ziplocs together with the silicate gel so that the samples would hold its relative humidity levels. So for the testing purposes, each of these polished section has a copper strip attached to them. It is done so that the plating with gold and carbon would be much more even. After coating with the carbon and gold, each of these samples have 5 zones drawn to them. It is done so that the tracing of the zones in SEM is much more easier, as well as the zones represent the specific parts of the polish section, and they represent the mid, center parts, and the outer parts of the uh, polish section, as it's shown on the bottom middle and bottom right image. So each of these zones hold 24 to 28 images, and they are compiled into one image using Adobe Photoshop. Afterwards, the exposition is corrected so that the dividing into layers would be much more easier. Each of these images then is divided into layers, for instance, matrix layer, filler layer, reinforcement layer, etc. And each of these layers have specific RGB code attached to them that is afterwards used to count specific layers pixels or quantitative amount of the layer in contrast to the whole image. So from the results, as you would imagine, we can see that the steel cord reinforced samples have significantly higher compressive strength, as well as the shrinkage and creep strength for reinforced specimens is significantly less than the plain specimens. As for the quantitative image analysis, there is two basic conclusions that we can make. First of all, the uh, specimens that are reinforced has significantly higher air void amount than the plain specimens. For instance, the difference for the specimens that are reinforced is 19% higher air void amount than the specimens that has no reinforcement in them. And as for the differences between specimens that has been subjected to the loading or creep specimens, in contrast to shrinkage specimens, for plain specimens, the difference in air voids are 1.62% in benefit to the shrinkage, not shrinkage, but creep specimens, and 2.31% for the reinforced specimens, again in favor for the creep specimens. So basic conclusions, what we can draw from here is that specimens with steel cord incorporation hold a bit higher air void amount than plain specimens. Basically, it's because when the specimen mix is mixed by adding fibers, the air incorporation into the mix is much more higher. And even though the specimens are formed by vibrating, not all of the air can be taken out by this procedure. Also, the middle parts of the polish sections hold slower amounts of air voids. For plain specimens, it's not so significant. The difference there is 1.2%. In contrast to the outer parts of the polish section, but as for the fiber reinforced specimens, the difference is 5.6%. So that the middle part of the polish section has 5.6% less air void amount than the outer parts. Also, sadly, there are no direct links between the long-term properties such as creep and shrinkage and the cross-section composition. But if the specimens would be tested into greater strength, I mean here higher, like in a unlinear state, that would be 60 or 75% load from the specimen ultimate load values, then the microstructure of the specimens would be much more damaged or influenced by the load, so they could be seen higher amount of the differences there, and they could be linked to the creep strain development throughout the testing. Thank you for your attention, and any questions?